Thanks to the hardworking Gaia spacecraft, astronomers think they've located a star that formed from the same solar nebula as the Sun. In fact, this star is a virtual twin of the Sun, and it's actually pretty close, well, astronomically speaking. It's been about 4.6 billion years since the Sun and planets formed from the solar nebula, a huge cloud of gas and dust left over from the Big Bang, and seeded by heavier elements from nearby supernovae and neutron star collisions. Over the course of millions of years, the stars in the solar nebula formed, the most massive of which died short, violent lives, detonating as supernovae. The less massive main sequence stars like our Sun stuck around long enough for solar winds to blow out the leftover gas and dust. And then the chaotic gravitational interactions with other stars in the Milky Way caused the stars to drift apart from one another. What started out as stellar siblings just drifted apart to lead separate lives, just like a human family. The solar system completes one full orbit around the Milky Way every 225 to 250 million years. In fact, the Sun has only gone around the Milky Way about 20 times in its entire history. The last time we were here, dinosaurs roamed the Earth. Astronomers are pretty certain the Sun didn't form alone in the solar nebula. But where did all the other stars go, and can we ever find them all? Some of the most familiar and dramatic objects in the night sky give us a picture of what the solar nebula must have looked like in the past. A good example is the mighty Orion Nebula, a region of sky about 1,300 light years away that contains neutral gas and dust, collections of stars, and hot glowing gas. At least 700 different stars are forming within the Orion Nebula. In fact, astronomers think that there have been at least 3 different waves of star formation in the Orion Nebula. Over time, though, the powerful stellar winds and rotation of the nebula will clear out all the gas and dust, shutting down star formation for good. As it evolved over millions of years, our solar nebula probably looked more like the Pleiades cluster. This collection contains about 1,000 separate stars, and it's located about 448 light years from Earth. Those stellar winds I mentioned have done their job and cleared out the intervening material. Individual stars are still surrounded by material, but it's being blown away out into space. As the stars continue to drift apart from each other, you get something like the Hyades cluster. It's located just 153 light years from Earth and contains hundreds of stars, which are estimated to be 625 million years old. It's now just a collection of stars, drifting farther and farther apart from one another until eventually we won't be able to see them as a collection in the sky. But the stars in the Hyades cluster are related. They all have the same age, motion, and chemical signatures. So, can we use these similarities to find the Sun's siblings? The hundreds of stars that formed with our Sun and have now been scattered across the Milky Way. Astronomers have tried to answer this question and tried several approaches, and a few possible candidates have turned up. One star turned up in 2014 called HD 162826. It was very similar in age, but was slightly hotter, 15% more massive, and slightly more rich in metals. A team from the University of Texas at Austin found the star by searching for specific rare elements like yttrium and barium. This was a surprise. Astronomers didn't expect to find a sibling of the Sun when only a small portion of the Milky Way had been cataloged. Just a few thousand stars hidden among more than 100 billion in the galaxy. But now, thanks to the most recent release of data from the European Space Agency's Gaia mission, astronomers have much more information to work with. Scientists working with Gaia released an enormous amount of data in April 2018, Data Release 2, which contained the positions and movements of 1.3 billion stars, with more coming in the future. Now, I've done a whole video about the most recent Gaia data release, and you should really watch it to better understand the treasure trove of information available to astronomers. But it would also be safe to say that I could just do a video every week about some new discovery made by Gaia and never run out of topics to cover. An international team of astronomers took this Gaia data and matched it up with a comprehensive galactic archaeology project called AMBER. This was a collaboration between the European Southern Observatory and the Côte d'Azur Observatory to catalog the atmospheric chemical fingerprint, or spectra, of more than 230,000 stars. The movements of all the stars from Gaia allowed them to trace back stars that started out in the same region that the Sun came from. And the stellar spectra from AMBER allowed them to find stars with the same spectra as the Sun. By comparing these two catalogs, the researchers turned up only a single match, HD 186302, and we'll talk about this star in a minute, but first I'd like to thank Mark Sheeran, Bill Nash, Josh DeRoos, Umu, John Gale, David McFadden, Ethan McAfee, Dan Morris, and the rest of our 825 patrons for their generous support. If you love what we're doing, you want to get in on the action, head over to patreon.com/universetoday. As I mentioned earlier, HD 186302 is a virtual twin of the Sun, a G3 type main sequence star with a surface temperature that matches the Sun. It has the same chemical composition as the Sun in its atmosphere, and it has the same age, roughly 4.6 billion years. According to Gaia, the star is located 184 light years away in the constellation of Pavo. And right now, that's pretty much all we know. With this discovery made, astronomers are planning to make follow-up observations with the European Southern Observatory's planet-hunting ESPRESSO instrument to search the star system for exoplanets. This instrument can directly observe planets orbiting other stars, regardless of their angle, so we don't need the planets to be perfectly lined up from our vantage point. Although astronomers have found other stars like our Sun, we can only really know their age, temperature, and the chemicals in their atmospheres. Our knowledge is only skin deep. But if this star truly formed in the same solar nebula, then it should have had access to the same mix of heavier elements. So does this mean you'll get the same kind of planetary system? Does it increase the chances of finding Earth-like planets in the habitable zone of another star? Or even with identical stars, do you get radically different planetary systems? Just like twin studies are incredibly helpful for understanding human beings, a true stellar twin study will help us understand which ingredients contribute to which kinds of planetary systems. I suspect HD 186302 will become one of the most studied stars in our region. I'm sure this is just the beginning. Astronomers have only scratched the surface with the Gaia data, and future releases from the spacecraft will help them find even more candidates. In the coming decades, we might eventually learn about dozens of other stars that formed with the Sun, ideal places to test theories about planetary formation and the search for life. What do you think? Let me know your thoughts in the comments. Once a week, I gather up all my space news into a single email newsletter and send it out. It's got pictures, brief highlights about the story, and links so you can find out more. Go to universetoday.com/newsletter to sign up. And did you know that all of my videos are also available in handy audio and video podcast formats, so you can have our latest episodes show up right on your audio device? Go to universetoday.com/audio or /video to find the one you want, and I'll put the links in the show notes. And finally, here's a playlist.